The bending stress or flexor formula, flexor formula or the bending stress formula, which is calculated by MC by I. Pretty straightforward, but sometimes the calculation of I can be a little bit tricky. We can also express this formula as FB equal M by S, because I by C is equal to the section modulus, the geometric property, section modulus, which is expressed by S, capital S. So that's the formula to calculate the bending stress. Now general shear formula is used to calculate the vertical shear, FB equal to Q VQ by IB. The same way we calculate the I, and this shear comes from the bending moment shear force diagram, the shear force that we calculate. So V is shear force, M is the bending moment. Now what is tricky here is this area moment Q, to calculate Q. Let me give you an example. Imagine that we want to calculate, this is a complex section. So we have a complex section like that, and then we want to see what is the vertical shear stress at XX section. Let's name it some other section. XX is used as a neutral section. Maybe Z is used for another thing. Let's use M1, M2. Let's say this M1, M2 is the plane that we are interested in to calculate the shear stress. What is oftentimes is done by mistake is calculating the Q, the area moment. So if we are interested in on this M plane or M1 plane, let's say MM plane, then the area moment is basically for these two pieces of the area. So if this one we define by 1, and then this small piece we define by 2, so basically this area moment is A1 Y1 plus A2 Y2. This Y1 Y2 is the center distance from this centroid of this small piece from the neutral axis. So that's Y2, and then Y1 would be this distance. So that's Y1. So that is how Q is calculated, which is done wrong oftentimes. So when you use this vertical shear formula, B is the shear force, that's fine. Q, you must be careful, and I sometimes can be tricky to calculate for a complex piece with respect to the neutral axis. In this case, this I is still IXX. So this I in the equation is basically IXX, the moment of inertia for the entire piece of the cross section, not just that upper part. So I is the entire piece. However, this Q is the whatever plane we are interested above that. If it's a bottom section, then whatever plane we are interested below that, like that. So if we are interested in something, let's say on this plane, this is the MM plane, and this is our neutral plane, then the area we should be calculating, the area moment Q is this and that. So that's what we should use for the area moment. I hope this helps to avoid that mistake.